Welcome back, everybody. Today we're going to be doing some graphing of sine and cosine. Before we do that, before we actually put these on a graph, let's just take a tiny look back at some very easy spots to graph. Because things like radical 3 over 2, that's a hard point to graph. So if we think about these locations where we know the answers are zeros, ones, and negative 1. This is the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So we're going to focus on the sine of the theta, first of all, which is, of course, as you know, the y values. We could graph 1/2 probably also very easily. So if we remember that pi over 6, all right, this is the point radical 3 over 2, 1/2. So we're looking at 1/2 there. So the pi over 6 values will also be easy to graph. I just want to graph this pretty specifically and exactly this first time so we can see exactly the pattern and get kind of a nice smooth graph. So let's just start there. You can see that the x-axis is no longer really the x-axis. This is now our theta axis. And of course the y-axis is still the y values. So when we graph these, we're going to graph the angle and then the sine of that angle. So it would be as if to say like the sine of 0 equals 0. So the sine at 0, that value is 0. The sine at pi over 2, of course, is 1. Now we've got a nice dotted line up here. This is just to help you, because there's no grid, this is to help you keep everything in line so that we don't end up being lopsided or have a spot that looks higher or lower than another one. If we go to pi, the sine is 0. If we go to 3 pi over 2, the sine is negative 1. And 2 pi, it's back to 0. Now the pi over 6, of course, awkwardly doesn't show up on the curve very well. So my plan to graph pi over 6 is not there. So let's think about the decimal value. Radical 2 over 2 is right around 0.707. So almost to 1, somewhere between 1/2 and 1 is the radical 2 over 2. And we also know in the second quadrant the sign is positive. So then this is another value. It's positive radical 2 over 2. So this will help us get kind of a nicer curve. Now you can see, and it's kind of an important pattern to realize, sine goes 0 up, 0 down, back to 0. If you can know that pattern, 0 up, 0 down, back to 0, it's just like the paint on that wheel. 0 up, 0 down, back to 0, 0. So it's like the paint spot on the wheel. The sine curve matches closely with that, which is why we did the paint spot. Hopefully now it makes a little bit more sense. So if we connect this, make it smooth. Please don't make it pointy, right? It definitely has a nice curve to it. We go to 2 pi. Now to go the other direction, we would just follow the pattern, right? This curve won't go turn around and go up again. It doesn't work like that. The way the periodic curve works, which is what this is the values repeat. So if it's on its way down right here, it's going to go down. Then at negative pi, it's back to 0. Now you could figure out these values, but you can also use the pattern of the curve to help you. So this is the sine curve. Some parts of the sine curve important to know: the domain is all reals, which basically means we can find the sine of any angle. However, the range, as you can tell from the graph, only goes from negative 1 to 1, which means we will not have an answer like the sine of some angle is 2. All right, so we can only have numbers between negative 1 and 1. The amplitude is how high the curve goes. So the curve basically gets measured from 0 up, like what is that space, or from 0 down. That space doesn't matter, that's your amplitude. So it clearly goes up 1 and down 1. So the amplitude of our function is 1. Now the period is how often does the cycle repeat. So if we think about the paint spot, it starts here, goes up, goes back. It takes all the way around to go to all the spots, all the positive and negative values. So our period is 2 pi, or an entire circle. this is important because the amplitude in the period is not the same for every function. So don't think, oh, of course it goes one time around. That's not really true. Like for tangent, it doesn't go all the way around. So we want to pay close attention to the amplitude in the period of the parent function. Does the graph have any asymptotes? And it doesn't. And you might think this is a dumb question, but 4 out of the 6 graphs have asymptotes. So most of the time you're going to have an asymptote. Does it have any local minimums? So it has a minimum, and again, pay attention to where they ask the question. They don't ask the question from the negative side, just from 0 to 2 pi. So we only have one minimum, and that's located at the point 3 pi over 2, negative 1. So that's our local minimum. That's the location of it. Some more questions about the sine curve here. If we think about what's going on at these spots, negative 3 pi over 2, okay, that's right here. Positive pi over 2, and then 5 pi over 2. So here's basically 4 pi over 2, one more is 5 pi over 2. So they're all coterminal, which means they all have the same answer, and straight up, of course, is 1. So these all have the same answer as 1, and of course we know that because they're coterminal. Is the graph symmetric around the y-axis? No, it's not symmetric with the y-axis. It has symmetry with the origin. So what this means is that it's odd. This is a topic in ALEX to do even and odd with your trig graphs, and that is helpful to know. So the sine graph is odd. And generally that's true about any graph that runs to the point 0, 0. So again, the number part H, it asks to repeat, is it even, odd, or neither? It's definitely odd. We're not going to go through the increasing and decreasing intervals because the graph is on the other page. Now let's take a look at cosine. And then we're going to put these together. And how do you know the difference between the two? How can you remember how to graph each one? So again, I'm going to come back to here to my unit circle. And this is 1, 0, 0, 1, negative 1, 0. And so, of course, the cosine are the x values. So we're dealing with x values instead of y values. So we're going to start here, of course, at 0. This is where we start. So at 0, the cosine is 1. So at 0 radians, the cosine is 1. So this thing starts high. That's as high as it's going to go. That's what those dotted lines are for. All the thing you can do from here is go back down. So you can tell here at pi over 2, we're at 0. At pi, we're at negative 1. And now all we can do from here is go up. 3 pi over 2 is 0, and 2 pi is positive 1. Now for this one, it really does look like a V. It is not, of course. Now for this one, we know that radical 2 over 2 is still 0.707. So we try to put that on here. But cosine in the second quadrant is negative. So at 7 or 3 pi over 4, it's negative 0.707. And this, of course, will stay negative. So if we can get some more points in there, this should have that same kind of rounded feel as the sine curve. So again, we know that it has to come back down here. And then we know it has to come back down here if this, oops, missed my spot here. Okay, that's terrible. I will tell you this, if you give yourself the points to aim for, the curve is much easier to draw, as you just witnessed. So that's what our cosine curve looks like. The domain, of course, you can tell there's no breaks in it, so it's definitely all reals. The range, just like the sine, the bottom point is negative 1, the highest we can go is 1. Here again, your amplitude, basically how high up does it go or how low does it go? That's your amplitude, from the middle up or from the middle down. And so the amplitude is 1. And then for it to go through an entire cycle, it starts high. In order for it to get back up high again, it does take an entire revolution of one circle, which is 2 pi. So sine and cosine do have those similarities. Now we're going to do increasing here and decreasing since we have the picture. So increasing, remember, you have to read it from left to right. So identify an interval from 0 to 2 pi. So again, 0 to 2 pi. We're only looking at this much of the graph. You've really got to pay attention to where they ask these questions. It's very important because it changes. So it only increases, it looks like, from pi to 2 pi, because that's where it's going uphill. It doesn't ask for decreasing. Describe the symmetry of the graph. You can tell that the y-axis splits it right in half, and you can tell that if you folded it on the y-axis, so we know it has symmetry with the y-axis, which means it is even. Now, if we think about, and I'm going to go ahead and just put the sine graph on here. Sine graph is 0, up, 0, down, back to 0. So here's the sine graph. So the sine and the cosine graph, they're just like off. They're just off like a half a beat, if that makes sense. They're just depends on which one you're looking at. It's like one's behind one or one's ahead of the other. And so a very specific way of describing their relationship is they are just a horizontal translation. Meaning one is just slid to the left or slid to the right, depending on which one you're looking at. Now, honestly, of all the things on here, this might be the most important. Doesn't look like much, but is in fact how we're going to graph these. So moving forward, this is what you need to have. You need to have the amplitude marked. So the amplitude is how high up does it go from 0 up and down. Then you need to have the period marked. So because we only really want to graph a few points, we're going to go 1, 2, 3, 4, period, halfway. That's how we're going to mark every single graph. So these graphs are weird. I'm going to come over here for a second. Normally, we give you a grid, and no matter what the graph looks like, we say, oh, this could be a parabola, this could be a straight line, we could have some polynomial, and you try to make the graph fit on the curve. We try to make the curve rather fit on the grid, if that makes sense. What we're going to do with sine and cosine is we're going to create the grid so that the graph looks the same every single time. Now, it might be a little taller, it might be a little lower, but it basically looks the same every single time. So now when we graph this, sine goes 0 in the beginning, middle, and end. 0 beginning, middle, that's why we want to mark the middle, and the end. And then the hard part is it go up or down? It goes up in between the first two zeros. So it goes up to the maximum, which in this case is 1. Then, of course, the only spot it can come is back down. So 0 up, 0 down, back to 0. If our period is 16 pi, if our period is pi over 4, if our amplitude is 7, the graph is going to look like that every single time. So that's the sine graph. For cosine, again, mark the amplitude. So we're going to go up and down 1. We go 1, 2, 3, 4, 2 pi, mark halfway. Now for cosine, it starts high. So it starts and ends high or at its maximum. Halfway between, it's at the low point. So starts and ends high. Halfway between, it's at its lowest point. Now the only way to go from up to down or down to up is to go through 0. And so the zeros are those other marks. So every single mark on this grid, we have 1, 2, 3, 4. We put a point on it. You don't have to put more than that. Please don't put more than that. It takes too long. It makes your graph look too junky. Now you don't have to do this super soon, but this is kind of a little sneak preview of what's coming up, so you can kind of get some anticipation as to how this works. When we put a number out in front, this is your amplitude. And we'll talk more, obviously, about the details of the graph, and we'll get all into that. But that's basically where the amplitude is. So basically you're multiplying, right? That's your vertical stretch. So normally it's a 1. So when you make it a 2, then you just double everything. So it's going to go up 2 and down 2. That's all that means. So let's real quick, I know you have that graph there. Let's graph y equals 3. They did sine. Let's do cosine. Let's see if you can remember the pattern. So we're going to go 1, 2, 3, 4, 2 pi, halfway, 1 pi. I know I didn't make my marks even. And then, of course, our amplitude, this guy, is a 3. 1, 2, 3. So we're going to go up 3 and down 3. So cosine starts high, ends high. Halfway, it's at its low point. It doesn't matter if my low point is a 1 or a 3. Then, of course, we have the zeros in between. If we think about what the parent graph looks like, oops, missed it. The parent graph is that. So that's what a vertical stretch by 3 looks like. It's not too much different. That's what I mean by we're going to make the grid fit the graph we want to draw. Now, if we're just sliding the whole graph up or down, we're going to move the midline up or down. You move the midline, and you count the amplitude from there. So we're still not going to change how we graph. So this says +2, which, as you know, means move the whole graph up 2. So here we go. This is going to be our midline. Now there is a 1 in front of this graph, which means we're going to be able to go up 1, down 1. So we have 1, 2, 3, 4. There's 2 pi, pi. This is cosine again. The cosine starts at its max. 2 pi, it ends at its max. Halfway, it's going to be at its minimum, which is down 1, which is at +1. And now our 0 turns into this dotted line. And so that's what the graph looks like. Of course, the transformation, we already knew what the transformation was, is just up 2. Now, again, that's not something that you're going to see too much until we actually go over it, like all the details in class or on a video, depending if you're virtual or if you're in school. But that's kind of the next thing that we do is amplitude and midline.